Well, good afternoon, good morning, everybody, depending where you're based out of. Let's get started and jump in. So my name is Matt Pino. For those of you who don't know me, I'm the technical sales representative here for Gusmer in the Northeast. So I cover Maine through Maryland, and I'm one of about 15 sales reps that we have throughout the country. Some of you may be my customers, some may not. Either way, we're glad you joined us today. So we can get moving along. And today we're talking about improving efficiency and mastering your spec with Denwel's carbonation and nitrogenation systems. One of my favorite words, nitrogenation. So hopefully we cover some good content today. And feel free to ask any questions you have at all. So jumping in, we try to keep it pretty easy, but hopefully there's a lot of good content for you. So first, we'll do a quick overview, Gusmer and Denwel both. Just if anyone's not familiar, anyone that's new to either company, make sure we at least touch on who we are and who Denwel is. And then we'll do a general overview of carbonation, nitrogenation. So it really just explains some of the basics of what's involved in the general process, but specifically in this case, really more inline is what we're focusing on. Some general tips. So some things to keep in mind, some things that you may be experiencing or things that we can help lend to and things that you would benefit from by going to an inline system. And then system operations. I'll actually pass off to my colleague, Mike Mazurko, and he's going to dive into really what some of the systems that Denwel can offer are able to achieve. And then lastly, Q&A. Any questions you have during this presentation, feel free to type them in the Q&A box. Really, we want to make sure we're here to provide some information, but we want to answer any questions we can. And that's something that we really want to make a focus on. Don't hesitate. There's no stupid questions generally, at least not the ones you're going to ask. So if you have it, somebody else probably has it, please send it over and we'd love to answer whatever questions you have. So starting off, and before we go in, if you do have any questions after the presentation, please don't hesitate. Reach out, go to our website. There's a find a rep section, and you can actually specifically put in your location and identify which rep is yours to speak with. And again, every single rep is all technically trained. We're all here to answer any questions. So don't hesitate, reach out, and we're happy to answer them. So who is Gusmer? If anyone is new to us as a company, so Gusmer, really our focus, our motto is service with knowledge. And that's the mantra we're going to be achieving today. But everything we do, we really want to provide a very technical, focused sales approach. We really want to help you as a customer and as a brewer to really see what is it you need. We don't want to just sell you something. We want to sell something that makes sense. So Gusmer is a company. We've been around a little over 100 years, founded in 1918, family-owned company. So the management and ownership both are still part and related to the Gusmer family, and we're our third generation at the moment. So 103 years later, we are still here, and we branch out quite a bit. Fermentation and filtration, food, beverage, pharma, quite a bit of focus, but we're pretty much spread all over depending what you're looking for. And we have facilities spread across the country. Again, we're a family company, but we are a national company. So we have facilities in California, some manufacturing, warehousing, and our support offices, our labs. We have manufacturing in Wisconsin, and we also have support, sales, and some warehousing out in New Jersey as well. So for anybody on the East Coast that I know, that's where your product comes from. And again, 15 direct technical sales representatives. So if there is something that you're looking for, we have somebody in your area that's happy to speak with you. So don't hesitate, give us a call. And specifically today, so we're talking about Denwel. And for Denwel, they're a privately owned company, family-owned, owners and founders, 1997. And Denwel is based out of Prague, specifically manufacturing in the Czech Republic. And their focus really is brewing, but they're also a global supplier for beverage, pharma, a number of industries for the past couple decades. So specifically when we talk Denwel, there's a really big focus on the cold block. That's where a lot of what we can provide and achieve is gained. And then they follow, as we have listed below, a number of different systems: inline, deaeration, blending, pasteurization, CIP. Essentially anything in the cold block that you may be looking for, there's something that we can probably provide or at least help look into a solution for. And Denwel is great because they really have a lot of standardized pre-engineered options, but there's also a lot that we can really custom engineer. So if you do have a focus of something you're looking for, we can provide that. So same thing, don't hesitate. If there's something you're looking for, this is what you're here for, and this is what Denwel's here for. And that's what we're here to talk about today. What can Denwel do? And specifically carbonation, nitrogenation. So let's look at that. So an overview, really, how does it work? And I think this is where we're going to get into some of the meat of it. Obviously, I think in this case, I think it's fair to say we're all generally familiar that beer is carbonated or beer has nitrogen. And how do we achieve that? So typically, in this case, it will be either done in tank. That's a lot of times done in tank for at least a kind of craft brewer scale, possibly a little bit smaller, but craft brewer scale, you're going to do that in tank. Home brewers obviously are going to be doing it in keg or even primed in bottle, but in tank is the most common, and forced carbonation is going to be the way to go. Denwel takes a different approach, and when we go to an inline side, this is going to really be a lot of benefits that are going to come into play. So how does inline work? And essentially, the gas is injected right into the beverage based on the injector that's designed here. If you actually look at the design, the gas is injected, the gas is split and creates these little micro bubbles that are actually going to provide the direct saturation of the gas right into the liquid that's going through. In this case, generally, specifically beer. And you're going to be able to carbonate or add nitrogen, whichever you're looking for. And the real big benefit is continuous process. So that's something that when we say, what does this achieve? It's a continuous, simple process, fits really nicely after filtration, centrifuging, and there's no mixing. You don't have to recirculate. There's no scissor stones. There's no candles. It's direct, easy, painless. Typically, in this case, if you do an inline application, we're going to fit the system either between filtration and maybe a bright tank or between two tanks. So either way, it's kind of integrated into your final step in the cold block process, that this is a step that you can achieve before your packaging. So in this case, continuous flow is the way to go. You're going to want typically a centrifugal pump is the best way to do that. And then essentially the receiving tank will be pressurized so that way we don't lose carbonation. And then in this case, we'll transfer beer from one side to the other, and then beer gets carbonated directly into tank, and it's ready to go out to packaging. Easy, simple, painless. And the other benefit in this case, in the overview of this system, is really it's CIP compatible. So when you look at the whole process, system's hooked up, pump the beer through, you need to clean it out. There's no parts you have to remove. The system designed to be fully inline solution, and it's fully CIP compatible. So in this case, you don't have to take apart. Stones are the biggest thing that we talk about, that based on the microns of stones and based on the design, they're very tough typically to CIP. In this case, you're never going to achieve the same CIP that you can with an inline solution. So in this case, the setup, you're going to CIP directly when you're done, and then you're ready to go. Then you go to the next step. So that's kind of at least the overview of how a system is set up. Very straightforward. The injector essentially is what's going to provide gas directly into the inline, and then beverage feeds back out. So very straightforward, but very elegant in what it's going to achieve and some of the benefits. In this case, let's talk about that. Major benefits of inline solutions. Really, it's ditching the tank. That's when we talk about what is an inline going to achieve. It's ditching the tank. And when we say that, really ditching the forced carbonation in tank or forced nitrogenation in tank. That's kind of the biggest benefit. So we say ditch the tank, go to inline. And there's three key parts that really stand out in what you're going to achieve in some of the benefits of going to an inline solution from Denwel. So in this case, savings in time. This I put as number one. I think it's a very often overlooked resource. But with forced carbonation, you're essentially going to have to spend time with liquid in tank that you can't touch. Depending how dialed in your process is, depending how familiar you are with forced carbonation in tank, can be numbers of hours, possibly even a day, possibly even more. And really, especially as we speak and review with craft brewers, tank space and time is a valuable asset. And that's something that as we look to see how can we maximize time in a craft brewery, that's virtual tank space, and that is money. So there is a payback here in time that really gets overlooked that inline can lend, because it's an instant solution. Essentially, as fast as you can continue to pump and match it with your either bright tank, buffer tank, whatever system you're going to, that's really what the time is going to be. Versus forced carbonation, you're going to spend a lot of time waiting and waiting. And then that's where efficiency gains come in, the physical resources of actually carbonation, nitrogenation. So depending on what you're doing and depending, again, how dialed in you are, this is a process that really can be pretty wasteful. It's not uncommon to speak to some brewers, maybe yourself or others, that depending how dialed in the process is, there's going to be some loss of CO2, and that's literally money floating away. And in this case, that's something you avoid with inline. There's complete use of gas. There's no loss of gas, and you gain a lot of efficiency just by containing everything within the product. Again, physical resources, you're losing a lot. Carbonation, it's going to be time and the value of the gas. Nitrogen as well. There's also efficiency gains made just in the actual ability to achieve that. Um, if someone can please correct me if I'm wrong, but I'm pretty sure nitrogen is about 1% as soluble as carbonation and CO2. So nitrogen, very much more finicky, a lot tougher to achieve. That process is going to be a lot tougher than a carbonation process will be. So that's something, just the mere physical resources that go into carbonating, nitrogenizing. Let's try to save them, and that's some of the gains from inline as well. And then improve quality of product. That's something we'll touch a little bit further on, but essentially, inline should be a very dialed in process, especially compared to a dialed in forced carbonation process or forced nitrogenation process. You should be able to get consistent, repeatable results every single time. And that's really our goal when we look at doing an inline system, is how do we get repeatability? How do we get consistent product? And by dialing in the system and by dialing in the SOPs that come with that, realistically, any brewer should be able to come, set up the system, and get the same consistent product every single time over and over. And ultimately, that's our goal. As much as we want to make sure you're making good product, we want to make sure it's a consistent product, something your customers can expect. So there are many benefits of ditching the tank. These are the biggest three. This is where I think a lot of it lends to. And then there's another half of this also, CIP. CIP is in place. Again, you don't have to dismantle anything. Nothing needs to be broken down. You really can't CIP a stone. It is feasible, but you're never going to achieve that as much as an inline system will. In this case, the entire system is meant to be cleaned entirely inline. And then also part of that as well, something that we didn't list on the slide, but safety. There is things to keep in mind with safety as a procedure with forced carbonation, forced nitrogenation in tanks. You really have to assure that the tank is set up for that. You have to assure that the tank is rated for that, and also ensure that all of your valves are properly in place. And regardless if you go to inline or not, one, I think, big takeaway, ensure that all your valves are set up as they should be. You really don't want to have to risk any kind of harm or injury to your employees. And that's something that with an inline system, the risk is much more mitigated based on that. You're not essentially creating a giant tank bomb. This is something where it's a constant, regulated, controlled process. Something not to be overvalued. Again, we want to make great beer, but we want to be safe. Inline helps to kind of avoid some of that while also gaining a lot of the other efficiencies that come with this process. So as we look at tips on really how do we best utilize inline systems, and some of these we touched on a little bit already, but a proper inline system really should lend to your QC program. And that's something that, as everyone grows and their QC programs grow with them and our quality programs, really helping to achieve, again, repeatable and accurate product every single time. You don't want to have to rely on the math of doing the wetting and the head retention and what does the stone achieve, and is your operator, your dial. There's a lot of variables that come into play that we really want to remove. So the biggest gain is how can we, again, minimize the time, but then achieving a better product. And that's essentially one of our biggest hopes. You can create standards that are easily dialed in by the brewers, the SOPs in place, so that way you can assure that this should be quality spec every single time in terms of carbonation levels, nitrogen levels, and really what you'll gain. Solutions should be matched to scale with downstream. And this is something I believe Mike's going to touch a little bit on. But really, typically as we set these up, you want to kind of understand, is it something you're going directly into packaging? Are you going into another tank? Ideally, we'd recommend you want to go into another buffer tank or at least some kind of bright before you go to packaging. And really the reason being that you want to understand if your packaging line goes down, that will affect inline carbonation. That will affect as the flow rates change. That's kind of dependent on pretty much a constant flow and how that's monitored and achieved depending on the system. But ideally, we would recommend go to a buffer tank. That way, your beer, your liquid is ready, and then you can go directly to packaging and then control just at the packaging speed. So that's the ideal setup. There are ways to look at this, and that's something, please reach out if you have a specific situation. But that's essentially what we would recommend as a best setup. And then there are multiple solutions, depending for CO2, nitrogenation, high concentration as well, combo skids. Review the big picture. That's something that we really would recommend is what are your short-term needs, what are your long-term needs? And obviously budgets aside, and we fully understand that, but if there's something with a combo skid and possibly even something pre-built, there could be a better benefit to getting a dual system, especially if you are using both gases. If you're making the switch, it'd be nice to make both switches at once. So that's essentially the setup of inline. I'm going to pass this things over to Mike Mazurko. I'm going to let Mike kind of do a general overview of how these systems work. Mike, the ball is yours, and tell us more about Denwel.
Sure. Thanks, Matt. Hi, everybody. My name is Mike Mazurko. I am Gusmer Enterprises product manager for brewing technology. And one of the lines that I deal with is Denwel. And we're very happy and proud to be their North American agent. So thanks for the intro there, Matt, and going over some of the baseline information on inline gas injection, specifically carbonation and nitrogenation, and some application tips. So now we're going to talk about some of the various systems that Denwel has to offer for these gas injection systems, and which one might be right for you, and what the differences are. So if we start talking about nitrogenation, the Denwel systems are usually able to deliver carbonation up to 3 volumes or 6 grams per liter. Nitrogenation up to 20 parts per million, or if we're talking about the high concentration nitrogenation, up to 80 parts per million. Of course, there's some other factors that are involved in this. As you can see, as we all know, temperature of the liquid is highly crucial to the ability of that liquid to absorb gas. Also, the pressure that it's under, the greater the pressure, the greater the potential for gas absorption. So as long as we understand those sort of baseline requirements, then we kind of know what we can arrive at with this equipment. Also, of course, there'll be a little bit of difference if you're going from something that's dead flat, which in a brewery for beer is usually pretty uncommon. We usually have at least 1 or 1.5 volumes before we start coming out of the tank. That's full chilled. The same thing is true with nitrogenation, depending upon the other gases that could be present, especially when we're trying to get to those high concentrations. The effectiveness of absorption could be limited to a certain extent. Next slide, please, Matt. Okay, so there are 3 basic configurations that we can talk about here for these gas injection systems, whether they're for carbon dioxide or nitrogen. There is a manual system, which is, as it sounds, completely manually controlled. Basically, you can see the carbonation version here in the upper left side of your screen there. Basically, you hook up your product line, inlet and outlet, and you hook up your CO2 supply, and basically you set the flow of the product and of the CO2, and carbonation is carried out in that manner. One of the nice things about the Denwel systems that are manually is they have a pretty thorough manual that comes with them, and a little helpful chart to kind of guide you along the right way as to how to get a little bit closer to achieving your spec in a manual setup. The next option is a semi-automated system. So these systems are PLC driven and are ratio controlled. So you've got ratio control valves proportionally controlling the flow of product to the flow of gas. And it's basically dialing in the CO2 based upon parameters that you enter for your specific brand into the PLC. And it's, of course, since it's PLC controlled, there's a little bit less room for human error or human interaction, which could maybe help in the precision of dosing. Maybe takes a little bit away from the art of what we like to do in our breweries. But the idea is to gain a greater degree of precision and accuracy with the ratio control in the semi-automated version. Kind of the upper end would be the fully automatic versions, and there's a very subtle difference between the fully automatic and the semi-automatic, and that would be that there is a CO2 analyzer or a nitrogen analyzer, depending on what gas we're working with here, that is controlling the feedback of the ratio control in the system. So basically, there's an actual read value of the gas concentration in solution on the outlet of the unit, and that analyzer is then controlling the flow rate of the product and the gas to achieve the input parameter that you've set for your brand. Next slide, please. So as briefly discussed here, manual carbonation would be a sort of the baseline piece of equipment here. And what I really like about these is that these are really pretty affordable units. I think they're probably within the reach of most breweries. The other nice thing about these mobile manual carbonation units is that, as you can see, it's a cart-mounted small skid that could be moved anywhere in your cellar to be between whichever tanks you need it to be. And then at the end, once you've CIP'd it and everything, you can put it away wherever, to get it out of the way of dragging hoses or other, things that are in your cellar that it could be interfering with. So again, as we discussed, you can add up to 3 volumes with these in line. Depends on where you start, of course. There are a range of sizes of these that would suit most breweries, from sort of the small to mid-size range. We have it in 1 inch, 1.5, and 2 inch, or DIN 25 through DIN 50. And this particular range can handle a flow rate from 9 to 85 barrels per hour, or 10 to 100 hectoliters per hour. So basically, how these things are sized are kind of based upon the lines that you use in your brewery, what size that would be, and what your typical flow rate is, or another way to think about it, how quickly you would like to process a batch within the parameters that you can otherwise meet in your brewery. As mentioned before, we have fully manual control here, both of the flow of the product and of the gas. And as I mentioned, not only is it value oriented and within the reach of most breweries, it's going back to what Matt touched on earlier, this is certainly going to be a more efficient, certainly time-wise, but probably also from resource use and manner in which to carbonate your beer than going in a batch carbonation by a stone in your bright beer tank. And again, relatively small dimensions, convenient, mobile, put it away when you're done. Next slide, please. And manual nitrogenation, we've got a picture of the unit here. It works in a very similar method. These inline injectors can do up to 20 parts per million. Of course, again, pressure and temperature dependent in one pass. And these manual units have a little bit of a larger range, from 1 to 6 inch, or DIN 25 to DIN 150. And as a result, can handle a much broader range of flow rate applications. So pretty much everything across the entire spectrum of breweries, from 9 to 852 barrels an hour, or 10 to 1,000 hectoliters per hour. Again, as with the carbonation system, we've got manual control for both beverage flow and the gas flow. And if you're looking to add nitrogen in line in your product stream, it is a pretty cost-effective way to do it. These would come, instead of on a cart, either in a wall-mounted application to mount in your cellar, or on sort of a freestanding skid, which could probably also have casters applied if that was something that you needed. Next slide, please. Okay, when we get into the semi-automated machines, we've got both one for carbonation and one for nitrogenation. And the addition rates of gas are about the same, again, up to 3 volumes for CO2 and up to 20 ppm for nitrogen. Pressure and temperature dependent, of course. And again, we have the larger range of sizes here, from 1.5 inch to 6 inch, or DIN 40 to DIN 150. And again, we have that higher flow rate that we can handle here, from 18 to 852 barrels an hour, 20 to 1,000 hectoliters per hour. And again, as we discussed earlier, the semi-automatic works in a ratio control. You've got automated valves controlling proportionally the flow of gas to product. And that is all done based upon inputs you enter into the PLC for your particular recipe and what your target is for your gas spec. Again, as I mentioned, they're programmable by brand. If you have a low carbon carbonated beer, like a mild ale or something like that, or some other type of British ale, or if you have a Hefeweizen, you can enter parameters that will allow you to get to the ends of the spectrum. And again, these guys can be freestanding or wall mount, and they're a little bit bigger than the manual carts, but still not necessarily space hogs. Also, if the standard dimensions for the particular unit don't work for you, Denwel is really pretty flexible in their engineering and are frequently willing to consider making a piece of equipment with custom dimensions, assuming that it's within reason of what the machine needs. Next slide, please. As discussed before, the full automatic version. There's also a version for carbonation and for nitrogenation. The gas injection parameters here are about the same as far as the rates that can be achieved, and as are the sizes. With the semi-automatic, they're the same. And the big difference here, as we mentioned earlier, is that you've got an analyzer reading what the gas saturation rate is. And it's that is controlling the feedback to the ratio control and changing the flow rate of the product versus the flow rate of the gas to give you basically the highest possible degree of precision in your gas injection. Who would want one of these? Well, anybody really, but it all really kind of depends on how tight your spec is. If you're someone who is really concerned about getting it down to the 1/100th of a volume of CO2, the automated version may be a better way for you to go than a manual or semi-automated version. And again, these are programmable based upon your brand specifications and what is desired for your final product. And as with the semi-automated, can be freestanding or wall mount. And also, again, as mentioned previously, custom dimensions may be possible if you have a limited footprint. Something we can always check into. Next slide, please. The last thing we want to kind of talk about is a little bit of a different animal as far as gas injection is concerned. And this would be the high concentration nitrogenation unit. And this unit is designed to give you sort of higher concentrations of nitrogen if you've got, like a dry stout or a milk stout that you would like to package under nitrogen and have sort of a real heavy cascade effect. Then this might be the piece of machinery that you're looking for, where we can put in up to 80 parts per million of nitrogen into solution. It has the option, as we mentioned, to your saturation on nitrogen is also kind of dependent upon what other gases are also dissolved in the liquid, in addition to the pressure and temperature that we're working with. So there's an option in this unit where you can have decarbonation as well, if that is something that you require in order to achieve the ultimate nitrogen spec in your product. It does come in a relatively broad range of sizes with a relatively wide flow rate from 18 to 426 barrels an hour. This unit is designed to be used between 2 tanks so that you can achieve this concentration going from one tank and then into the other before you go and process it on the filler. So it's a pump-driven, batch-oriented system that works on the principle of a membrane. And again, this could be cart mounted, so it's easy to wheel around, to place between whichever tanks you need it to be at. And again, within reason, there are probably some room for custom dimensions if the standard ones don't work, although this unit is, as you can see, relatively compact. Next slide, please. Okay. So that is my portion of the presentation, and I know Matt will come back too, and I see we have maybe a couple of questions here. So we'll start there, and if any others come up, please don't hesitate to ask.
Yeah, so we have a couple of questions for you guys. The first is kind of a two-parter. It says, could you discuss the advantages/disadvantages of the inline carbonator versus a gas liquid static mixer? How does it affect the flow through a line? I'm currently running at 385 hectoliters per hour.
Okay. Well, I'm not sure if I'm going to be able to exactly answer the question. If we didn't quite hit the element that you were looking for, please, as Matt mentioned on the Find a Rep, reach out to us and we can go in further detail, maybe back and forth on email or something, or on the phone. But so this injector basically is a venturi that kind of works on the Bernoulli equation and changing, the flow type and as it goes to the inline injector, and gives that sort of turbulent area for the gas to be injected. Works a little bit different than a static mixer system in that way. And then also, my experience and my knowledge of static mixers is that this type of a system, there's really nothing inside, so there are less places for soil to collect, and this would just be generally easier to CIP. Again, those are my quick thoughts. I'm not 100% sure if I answer the question, but certainly, there are units that would fit your flow rate depending on what we're talking about.
The next question we have coming in, does the meter read incoming, outgoing DO as well?
No, what we're looking here for, if we're talking about the automated unit that has an analyzer, that would have, if we're talking about a carbonation system, a meter on there for CO2 in solution, or if we're talking a nitrogenation system, a meter on there looking for N2 concentration in the beverage. We're coming out of a fermenter or off of a filtered beer or centrifuged beer source. So, while there are points of ingress for oxygen in line, if we're operating under best practices, those should be relatively minimal. If having a DO spec is important to you before you package, that'd be something you might want to do tank side at your bright tank. I'm sure it would also possibly be an option to add inline DO, but that probably won't give you the final answer before you go to your package. So again, if we haven't exactly answered the question, feel free to reach out separately and we can kind of go back and forth to discuss it further so we can get to the point of that you were looking to have answered.
Mike, it maybe is worth mentioning as well. I know this isn't the exact platform, but Gusmer does have different DO solutions if you're looking for any type of, either that's in tank, you want to do sample vat, or you want to do inline. We work with Hamilton, is one of our suppliers for that as well. So feel free, that's something we would encourage. Definitely reach out to your local sales rep and have a conversation with them. And we definitely can kind of combo that with some different things you're looking for.
Certainly. Yeah. And just to kind of harken back on it, in case you were not someone who was on the first in this series where we discussed inline gas injection specifically with wort aeration and oxygenation. Of course, when it comes to an automated unit in that range, they would have an analyzer on there looking for DO. So it's not that this doesn't exist or isn't possible. It's just that's typically in the standard units, not what we're looking for when we're talking about carbonation or nitrogenation, that is.
We have one final question, it looks like. How do you size a unit to your brewery?
Sure. I touched on this lightly when I was going through the different system setups, the different options, and basically there are a couple of different ways to do it. If you are a brewery that has all 1.5 inch hoses in your brewery, then we're going to look for a unit that's 1.5 inches, because chances are one of the options that are in that size is going to have a throughput flow rate that is going to sort of match what your typical desired batch processing time is. And that would be the second thing we take a look at too, is what's the volume of the tank that you're looking to process, and how much time do you want to process that in. And so that gives you a little bit of leeway on how to do it, in that if you are used to it taking 2, 3, 4 hours to carbonate by way of a stone in your bright tank by the time it's done, then you may be looking to make a modest improvement or a huge improvement, or go with a small unit and just have it trickle through if it works for you to go slower. So that would be basically how we would think about it, I think, unless there's anything else that you would add there, Matt.
No, I think that definitely touches on it. And, my thought, and I know we talked about this a little bit in best practices, but, essentially you generally would prefer to be going from tank to tank. And Mike, I know you can comment a little bit, but, you can in theory go directly to packaging, but there are some inherent issues there that if packaging goes down, you could potentially go out of spec based on the residency of the liquid kind of stays a little more stagnant. So you would ideally want to go tank to tank. So it is something that there's a little more flexibility, I think, in volume versus conversations I've had with other brewers that say, well, my canning line, my bottling line can do X amount of cans, X volume per minute, but that really doesn't necessarily need to be the X factor here. It's something that you can kind of dependent really on the rest of your process.
Yeah, I agree. Trying to keep up with your filler speed or whatever might happen can be tricky, depending, just in general. But then especially depending on the sophistication of your filler. And if you stop the inline gas injection process, then you're taking away, and the product in line is going to slowly warm up. You're going to have to start and stop the machine, the flow of the gas, and so your results are going to vary a little bit more, and like you said, you'll go out of spec. So ideally, yes, you would buffer it to some degree. If that's just to keep up with when the filler is jogging or is down momentarily, or ideally handle it in sort of a batch process where just instead of sticking the stone in the bright tank, you're running it from wherever in the cellar it comes from before the bright tank to the bright tank, and then it's still just all ready as a batch to package, so you can go and maintain your spec during your packaging run.
Absolutely, I think it answers that. I agree.
So it looks like that's all the questions that we have for today.
Okay. Well, again, if anyone does have any further questions at all, don't hesitate. Please reach out to Gusmer directly, whether it's sales or your local technical sales rep. This is exactly what we're here for. We're happy to dive in and do any more application thoughts you have. And let's also take one further look. So moving ahead, anybody that is interested, we do have 3 more Denwel webinars ahead of us. And specifically, the next one ahead, carbo blending and dosing systems, and really a little bit focused more on hard seltzer. So anyone that's looking to do hard seltzer at all or is interested at all, this is something that really we're going to touch on a lot of the aspects and what Denwel can offer, and also just what abilities and what things you should keep in mind. Second ahead is also water deaeration, very important. This is something that we talk a lot about with DO. If your water has too much DO to begin with, it's a lot tougher to start off with something to high DO than less. So water deaeration, very important. We're going to cover that at the end of July. And then the last one in the series is CIP, make your life easier. So CIP, crucial. The old adage that brewers are more janitors than we are brewers. CIP is going to be a big part of this. So this is something, again, what we can recommend, best practices, takeaways, and how we can benefit. And one more time, again, if you do need help or you're looking to speak with your local sales rep, just go right to our website, gusmerenterprises.com. There's a find a rep section, and then type in where you're at, and you can find your local rep. Could be myself, could be Tom here, could be anyone. We have about 15 sales reps across the country. There should be somebody local in your market. Please don't hesitate. Again, it's, the motto we say, service with knowledge, is what Gusmer really focuses on. So for us, our goal is to have a very technical conversation. We want to help find solutions that you're looking for, and not just things that we'd like you to buy. We want you to buy things that make sense for you. So have that conversation. That's exactly what we're looking for to have. Aside from that, I think that is it. Thank you very much for everybody that joined us today. We hope you kind of took away a little bit from this. If there's anything, either Denwel, either carbonation, nitrogenation, or anything else technically wise, please don't hesitate. Reach out to us, and thank you very much for joining us. We appreciate your time today.